Alright guys, I want to start off our discussion today with this diagram. And this is a lab that I was hoping to kind of do for you guys, a little demonstration. And it's a simple enough demo. The problem is I just wasn't able to get everything put together in time for today's lesson. But this is kind of very simple here. I'm going to show you kind of what's going on. At the bottom of this beaker is red wax. Okay, so basically it's just candle wax. On this grand cross layer right here, this is just the sand. And then we just have plain water sitting on top of it. Now, basically what we're looking at here, the wax is representing the upper mantle material. So what is the upper mantle? What's the consistency of that material? Okay, let me slow down on Monday morning. What is the upper mantle made out of? Not lava. Liquid magma. So molten magma, right? Okay. And also, if we're talking about the very upper mantle, we're kind of talking about the asthenosphere. So it's still somewhat pliable, it's somewhat plastic. Okay. And then we have the lower crust. That's what the sand represents. Again, if you think about it, the farther down you go, the warmer it gets. So that material is still solid, but still kind of movable. And then we finally have the upper crust. And then this is sitting up on a tripod, and underneath it's a Bunsen burner. Okay, so providing a heat source. What do you notice as we move from the left frame to the middle frame? What starts to happen? Yeah, the wax is moving. What's it doing? It's rising. Okay, tell me why it's rising. Okay, so why does it rise? Not so much pressure at this point. Why is the wax rising? Okay, so why does it rise? Here we go. Remember, we think about densities. So as this wax is getting warmer, the rest of the stuff is colder, so what does the warmer start to do? It starts to float up through the colder material, right? It becomes less dense than the surrounding material, so then it starts to rise to the surface. And we've seen this before in different diagrams. Remember we talked about subduction zones? You guys saw that magma that was in the subduction zone rising to the surface? That's because it is less dense than the surrounding material. So then, what happens when wax, molten wax, hits water? Instantly, right? Okay? So what we see here on the next frame is that we start to get this bubbling effect, where it kind of looks like a very, very thin stick of wax, but that very thin stick is actually hollow, like a straw. Okay, so while it looks like it's solid, the molten wax is still flowing through that tube. So when we think about volcanoes and how volcanoes form, this is literally the pipe that feeds into the volcano on the surface. Okay, that's a great way of thinking about it. As this wax starts to come up. What's happening right here? At the very top. Why is it settling on top? It's cold. Okay? What can we say that kind of looks like? Give me a real world example. What would that be modeled? Okay, so what is the red stuff again? That's magma. That represents magma. So then what is this stuff on top? Okay, it's lava. And what's that lava doing on the surface of the crust? So what would we call it? Very simple term. Lava flows. Okay, so think about Hawaii, right? When you had that magma basically just creeping across the surface of the earth. That's really what we're seeing right here. Given enough time, we're going to get more tubes that start to form. So we can see that right here in this frame on the far left where we have multiple tubes, and then again, what do we have on the surface? Lava flows, right? So we're getting that new crust being created. And then we get these really interesting structures of new rock. Now, again, I think it's really important for you guys to put this into context. Where the water represents the crust, correct? So the water was pre-existing rock, solid rock. So what is happening with these tubes? What is it doing to that rock? If the water was pre-existing rock material, then what is the candle wax or the magma doing to that rock in order to get to the surface? It just has to melt its way through it. That kind of makes sense? Okay. So that would mean, I want you guys to honestly think about this for a minute. That would mean then that I had this horizontal layer of rock, represented as green rock. And in comes my magma. From underneath. And then at that cooled and solidified, I get this new rock, right? And that is what we call an igneous intrusion. This is what we're going to be learning about today. Okay, so the title of today's lesson is Igneous Intrusion. And this is exactly what we have. We have the magma that's literally intruding itself into rocks. Okay, and I guarantee you everybody in this room has seen this before. Maybe you never realized it, but you've all seen it somewhere.